Hi folks, this is Cliff with Recreation Destination, and today we're continuing the Understanding Your RV series. We are focusing on electrical systems in this series, so if there are things you don't understand about your RV, you've tuned into the right spot. If you don't know a lot about watts and volts and amps and how your electrical systems work in a basic and general sense, then by all means click on the first video in this series and watch the two videos there prior to this one. Now we'll kind of catch you up on where we're at in this series. Today we are looking primarily at inverters. We're going to talk about inverters and the different types and different sizes and sizing your inverter for your needs, because everybody's needs will be different when dry camping with their RV. Also, if you're new to RVing, there are probably a lot of terms and terminologies that can be confusing at first. As I said, we're talking about inverters today. Now, there is something in your RV called a converter, and that is used to convert 120 volt electricity off of the pedestal in the RV park, or maybe you're plugged into your garage in the house, into 12 volts, and that charges your batteries and runs a lot of the systems in your RV. Again, go back to Understanding RV Electrical Systems Part 1 for a more detailed description of that. An inverter does the opposite job. It takes 12 volt electricity, runs it through processes, and you end up with 120 volt, 60 hertz alternating current. Things that you normally have to be plugged in to use, you can then use the inverter. So a quick rundown on some things that probably are 120 volts in your RV are the air conditioner, your microwave, of course all of the receptacles. Your water heater may have electric heat option, and in that case that's going to be 120 volt also. Of course, items in the entertainment center are almost always 120 volts. Occasionally you'll see the exceptional 12 volt television, and that's why they still have this strange little 12 volt power port in the entertainment center areas in a lot of RVs. There are two types of inverters you're going to find in RVs. There is what is called a pure sine wave inverter, and there's a modified sine wave inverter. Now, if you hooked a pure sine wave inverter to an oscilloscope, which is a device that electronics technicians use, you would see that a pure sine wave inverter puts out a nice sine curve as it alternates. It's very rounded. But with the great invention of the field effects transistor, it basically changed all of electronics and made all the electronics that you probably have possible. Smartphones and computers and all of this work off of field effect transistors, and the modified sine wave inverter is no different. Basically what it does is take a square wave and turn it into stair steps, and in this way it mimics a sine wave, but they're not perfect. And one of the things that you will find with a modified sine wave inverter, depending on the piece of electronics that you have plugged into it, is they will create a buzz, and that modified sine wave sounds like this. However, the modified sine wave inverter does come with some great benefits. One of these benefits, of course, is cost. Inexpensive circuits make a product less expensive. So what you're going to find, watt for watt, in production is pure sine wave inverters produce a much cleaner electricity. Modified sine wave inverters produce a lightweight and less expensive electricity. So initially, when you compare a pure sine wave inverter with a modified sine wave inverter, what you're going to find is the modified sine wave inverters are smaller, lighter, and much less expensive than a pure sine wave inverter. So it seems like a no-brainer in an RV that you would want a modified sine wave inverter. Not to mention the fact that the great majority of inverters you're going to find any place except for a place that specializes in high-end inverters are going to be modified sine wave. However, there are some drawbacks to modified sine wave inverters. As we explained, that stair-stepping action that a modified sine wave inverter uses to duplicate or mimic that curved sine wave has some problems with electronics. It will make something as simple as an electric motor buzz more than it does on pure sine wave. Some electronics won't work properly. Some electronics won't work at all. And a small amount of electronic products can actually be damaged by a modified sine wave inverter. But one of the most important things that I should mention right up front is things like CPAP machines. Your life depends on them operating. It's recommended you don't use a modified sine wave inverter. And it's worth mentioning that you can operate a lot of household appliances with a properly sized battery bank and inverter. Again, I know most part-time RVers are not going to be interested in doing such things, but it is possible and it's worth mentioning. For instance, we ourselves have 450 amp hours worth of battery in our battery bank. We have 800 watts of solar panels, and we have a 3000 watt inverter. Now, all of this together allows us to be able to use the microwave without sapping a lot of our battery storage. So now we're not cooking Thanksgiving turkeys in there, but we can certainly make a bag of popcorn or reheat a little dinner or something without any trouble at all. And as I was saying, some electronics are going to have issues with a modified sine wave inverter. You're possibly going to get noise out of audio electronics such as televisions. In my particular case, the laptop I have, which is a Dell, I don't have any issues with sound coming through the speakers, but if I record on my computer while using the inverter, I do get that 60 cycle buzz coming through the microphone, and it's not a microphone issue, it's an inverter issue, so that's something I have to be aware of. Now, fortunately it is a laptop and it has a battery, so I can just unplug it to do my recording, and that clears the issue up. But that's an example of an issue that you can have. Some items have more severe issues. Our 47-inch flat screen television, for instance, the hum just in having the television on the inverter is really too annoying for us. It's a Vizio, and perhaps the other televisions won't have as severe an issue as the Vizio does, but you'll find that different electronics will react differently to modified sine wave inverters. And we have it on good authority that Sony products in general tend to have more problems with modified sine wave inverters than other products. So let's talk a bit about inverter sizing. You can get inverters from a very small wattage output, such as this little guy, which is a 100 watt inverter. And you can find one like these. They plug into a standard 12 volt power port cigarette lighter type plug, and this one puts out about 100 watts. You can get these at auto supply stores and places like that. Find these online. I think I gave like $29 for this little inverter. We keep this one in our car, and this one's is only got one 120 volt receptacle, and then it's also got a little 5 volt USB port for charging some small stuff. But this one will run a laptop okay. It will run the wall warts for different types of battery chargers for cameras and cell phones and things like that if you need that capability. And it's nice, it'll fit in the glove box. Keep that in the car. Or you can get inverters up to several thousand watts. To size your inverter, since everyone's needs are different, your best move is to do an energy audit. And an energy audit is simply to try to find out how much electricity that you use, or you will need to use, or you will want to use during your dry camping periods. The 120 volt appliances that you choose to use are going to have a range anywhere from milliwatts for small things like phone chargers and power supplies, up to perhaps hundreds of watts or even thousands of watts, such as a microwave. In an RV, it is practically impossible to have enough battery power and solar to run an air conditioning unit. An air conditioner will normally pull about 3,500 watts to start, and they'll run anywhere from 2,500 to 3,000, a little over 3,000 watts while running. that would sap even the most robust battery bank in no time. You might get an hour or two out of a great battery bank of air conditioning, so it's not a practical use. Microwave's a different story. Even though a microwave is maybe 800 to 1200 watts, ours is 1000 for instance, you're running it for 5 minutes. So it's got a lot more usability. Something like a crock pot uses very little electricity. Our crock pot, or as some say, slow cooker, only use 265 watts on high. So we can reasonably, especially with the solar panels, turn the crock pot on and cook up a big pot of ham and beans or soup, anything like that, and it doesn't draw that much on the batteries. We also carry a 5 cubic foot chest freezer with us constantly, and it's almost always running. And surprisingly, it only draws 160 watts. On the other side of the coin, our electric skillet draws 1200 watts, which if you divide that into 13 volts, a fully charged battery, you're going to have 92 amps of draw on your battery. If you've got a 100 amp hour battery, using that skillet for an hour is going to drain your battery. But it's still something that we can use. Having 800 watts of solar on the roof and 450 amp hours of battery reserve, we can reasonably go ahead and make some breakfast in the electric skillet without a problem. But these are just some examples from our life. So what you would want to do is find out how much 120 volt usage you expect to have in a reasonable situation, and then size your inverter for that. Perhaps you could get away with something as simple as the 100 watt inverter I showed you. Maybe you'll need a 600 watt, 1000 watt. We did relatively well for quite a while with a 750 watt inverter. Then we moved to a 1000 watt inverter. It did a little bit more for us. But ultimately, being full-time RVers, we chose to have a 3000 watt inverter that would run anything we would want to run for a limited amount of time without sapping our batteries. Now you can find your energy usage and wattage ratings somewhere, usually on a tag or stamped into an appliance, and that will tell you what that appliance draws. And that's generally a maximum draw on that appliance. It may draw quite a bit less. You can definitely get a good ballpark off of the stickers and find out exactly what you're going to be looking at. However, if you really want to get technical, you can get devices that actually measure wattage ratings or wattage draw in real time. There's a device, for instance, called a kilowatt. You plug it into your receptacle, then plug whatever appliance you have into the kilowatt, and it will tell you how much it's drawing. So I expect that's quite a bit of information to absorb for one day. So we're going to stop here, and the next time we pick up in this series, we're going to talk about different ways to wire up an inverter, especially a hardwired inverter. So hopefully you've picked up something new from this video series. And if you've got any questions, as always, leave a comment below and I'll answer that to the best of my ability. I'm not an electronics technician, nor am I an electronics engineer. I'm just a guy that's been RVing since 1992 and's got a little bit of information that I've learned over the years to pass on to you.